Hi, my name's Abigail Voronyak,
And I'm Nathan Kawlewski.
and we are mathematics majors here at Concordia, and we are part of the ERSCA Summer Research Program, and we are working with Dr. Seeger from the math department on virtual knots.
So when we started the summer researching, we were interested in looking at crossing weights, which, if you're unfamiliar with that, is a summation of the sign of crossings and their intersection number in the Gauss diagram. And when we started looking at crossing weights and crossing weight number, we noticed some characteristics of classical knots and virtual knots. In particular, that classical knots always had their crossings having weight 0, and certain virtual knots did as well. But we were interested in finding if there was a way to kind of connect those two things, the classical and the virtual. And in particular, we were looking for a move to take a knot from a classical knot to a virtual knot without changing the weights of the crossings.
So I can share my screen here. Okay. So one of the moves that we were able to find is that if we take single wave virtualization and apply it to the crossings, we were able to make a classical knot into a virtual knot without changing the without affecting the crossing weights. And that just changes how the strand goes into a crossing. You can see that it's an overcrossing here, and it changes to an undercrossing here. We were able also found something called double sign virtualization, which does the same thing in that it turns a classical knot into a virtual knot and it changes the sign of a crossing. As you can see here, it's positive, and then over here it's negative, and it does not affect those crossing weights. And we were actually able to prove both of these.
Some of the other results that we have come up with during our research time is we were able to kind of modify the invariant of the crossing weight number, and particularly for those crossings with weight 0, because it failed to be an invariant under all the Reiter-Meister moves. And we were able to do that by subtracting the rise of a knot from the crossing number due to the crossing weight 0. Another thing we found is characteristics of virtual knots with crossing weights and the generalized Alexander polynomial, in particular, that they must have a generalized Alexander polynomial of 0 if all their crossings are to be 0 as well. And we've also been working on some a new move as well here at the end of our research, what we're calling a triangle virtualization, which is essentially like an R3 setup, and then applying a single way or single sign at each crossing. So it's going to be similar to like a double way, double sign, but applied to 3 crossings instead of 1. And we're working on that move here as at the end of our research. And we're hoping at the moment, we're also hoping to publish a paper, and we're working on that paper at the moment here. And hopefully we'll get that done here at the end and get it published. So thank you for your time.